What caused an air force that was in many ways vastly superior to the Allies to come crashing down? Is there a distinct turning point that made Germany's aerial arsenal impotent against the combined strength of Britain, America, and the Soviet Union? For the first time ever, put yourself right in the middle of the debate as we try to solve the greatest arguments in the history of aviation. What caused the Luftwaffe to fail? In 1933, Adolf Hitler becomes Chancellor of Germany and later the Führer, enacting complete control over the fatherland. Eager to reclaim the lost territories taken from Germany after the Treaty of Versailles, the Nazi war machine realizes early on that the formation of a strong air force is vital. In 1935, it becomes official on paper, and the Luftwaffe is born. The man put in charge of this department is Hermann Göring, a prominent ace from the Great War.
Göring was a World War I fighter pilot. He was not interested in technology. He said something at one point, he said, well, this device is a box with coils, and I don't like boxes with coils. He still had this sort of, well, if you're courageous and brave, you don't have to worry about technological gizmos.
In building this new air force, the Nazis possess many advantages that other nations do not, including a first-class aircraft industry, symbolized by the names Messerschmitt, Dornier, Heinkel, Junkers, and Focke-Wulf. Brilliant engineers capable of taking aerodynamics to a whole new level, and a highly educated population that can build aircraft on a mass scale. By 1938, production rises to over 5,000 planes. 1 year later, that figure soars to over 8,000, a testament to the importance Nazis place on the doctrine of air power.
What the Germans were trying to do was to employ new machines, new technologies, but to employ them in the service of a very, very old way of war that had served them well in previous conflicts and they felt would continue to serve them well in the future. I think this sets the Germans somewhat apart from neighboring countries in the 1920s and 1930s in that they are not truly looking ahead as much as they are looking back to their old traditions and grafting new technologies onto them.
Before war is declared in August of 1939, Germany's aerial arsenal is impressive to say the least. Ready to go is the Me-109, a superior single-engine fighter, the Junkers 87 Stuka, a terrifying dive bomber, the Heinkel 111 and the Dornier 17 Flying Pencil, two top-of-the-line medium-range bombers. This, in addition to the largest air transport industry in the entire world, exemplified by the Junkers 52, a workhorse that will be at the centerpiece of the German offensive. Even with all these phenomenal aircraft, a key ingredient is missing, as is often noted by Second World War historians: the absence of strategic bombers. This void does not go unnoticed in 1935, when General Walter Wever, realizing their importance, enthusiastically supports the building of long-range aircraft to battle any potential enemy, most likely the Soviet Union.
General Walter Wever was promoting what he called the Urals bomber. He believed that the industrialization, tanks, planes, etc., that was going on in the Urals area had to be demolished if you were going to win a war against Russia.
Wever writes, "Air power carries the war right into the heart of enemy country from the moment war breaks out. It strikes at the very root of the enemy's fighting power and of the people's will to resist."
Yeah, Walter Wever was very much in favor of this long-distance bomber to try and bomb Russia. And that actual project was given the name of the Ural bomber. Wever actually then put specifications out to both Dornier and Junkers for the building of this long-range bomber. Out of this came the Dornier 19 and the Junkers 89. But neither of these aircraft had the performance that was currently available in the United States of the B-17 Flying Fortress. So therefore, neither of those airplanes really progressed very far beyond a couple of prototypes.
Dying due to a plane crash in 1936, his doctrine epitomized by the Dornier 19 and the Junkers 89 are scrapped by Göring.
Göring, I think, didn't go along with this because he rather took the view that Hitler had, that they could win by Blitzkrieg, and they wouldn't be required to get into this lengthy process of using heavy bombers.
Inquiring as to how many twin-engine planes can be made for every 4-engine one, the answer given to him is 2.5. The Field Marshal's response is that the Führer does not ask me how big my bombers are, but how many there are. It is important to note that the decision not to build long-range bombers cannot be considered a failure. For Germany, the raw materials needed to build such planes would require large amounts of rubber, metals, and fuel, all of which would have to be imported for a hefty price. Of the 4,500 tons of aluminium needed per month for aircraft production, only half is available during the Wefer era. The Air Force that he and others envisioned was simply uneconomic at the time. What truly represented the German way of war is instead a tactical Air Force.
The German War of Movement attempted to defeat as much of the enemy army as possible within the opening weeks of fighting. So the tactical level of fighting for an individual position, and then the operational level of attempting to defeat an enemy army. But arguably, Germany had never been very good, and this would go back to Prussia before it, at the kind of long-term strategic planning that the Allies were so skilled at in World War II. Arguably, this was because the Germans felt they had to win all their wars quickly or they would not win them at all, and that attempting to play strategic warfare with the vast economic and industrial resources of the United States was a losing game from the start.
Working closely with those on the ground, the Luftwaffe is wildly successful as the Second World War begins. Poland is easily demolished. Norway is taken away from the British effortlessly. The Low Countries and even the power of France cannot resist German might during the year 1940. It appears that nothing can stop Nazi forces from gobbling up the continent of Europe.
Certainly the Luftwaffe played an extremely important part in the opening German victories of World War II. And when we say opening victories, we don't mean the first 6 months, we mean the first 2 years, in which it looked like a German victory was very much in the offing. The German Air Force was very skilled at the tactical level, that is, cooperation with the ground forces. It was extremely successful at the operational level of war, the intermediate level, that is, carrying out campaigns against enemy supply lines, for example, feeding troops and men to the front.
With the fall of France, Britain is the only nation standing in the way of this German juggernaut. In order to finish off the rebellious island nation, a plan known as Operation Sea Lion is approved. It calls for the Luftwaffe to achieve air superiority over the English Channel. Once this is completed, German forces will be deployed onto British soil. However, during this pivotal battle, the Luftwaffe is dealt its very first aerial defeat. Primarily through the use of Spitfires and Hurricanes, the English are able to push back German planes from the coast to Britannia. While this monumental struggle ensues, we discover one of the Luftwaffe's greatest failure, its lack of coordination with the Kriegsmarine.
Göring said, everything that flies is mine, and bitterly fought against any attempts by the German Navy to get a hold of a piece of the air action. When they wanted long-range aircraft assigned to them, Göring, actually, Dönitz went behind Göring's back directly to Hitler, and I think got a dozen of the Focke-Wulf Condors assigned to him. Göring, when he found out about this, was furious and actually cut off all cooperation with the Kriegsmarine at this point.
Despite pleas by Admiral Raeder to create a separate air force for the Navy, Göring refuses to give the green light to any potential inter-service rival. The roots for this conflict come from each service's desire to be recognized as the one who brought victory to the fatherland.
Of course, there has always been the rivalry between the Navy and the Air Force from the point of view that we refer to ourselves as the Imperial Navy. and referred to the Air Force as the Nazi Air Force. So that differentiated us already in attitude and character.
In hindsight, Göring's decision proves fatal as Germany and Britain battle it out in both the skies and on the high seas. Winston Churchill would write that the greatest threat to Britain was the Battle of the Atlantic, where German U-boat submarines are enormously successful in sinking English shipping.
I think Churchill was quite correct that the Battle of the Atlantic was the one front where Britain could really lose the war because they were so dependent on supplies, even food, coming from North America, that if that lifeline was cut, Britain would have been really in dire straits.
With the defeat of France, bases are built right on their coast, giving these vessels an even bigger theatre to disrupt the lifeline of Britain. Had aerial forces worked closely with these U-boats, or if a separate naval aviation wing was created, it would be a game-changer in Germany's war against Britain. Proof of this can be seen in the Focke-Wulf 200 Condor, an aircraft that, despite its limitations, is excellent in attacking English ships. With no more than a dozen planes, they successfully sink 85 merchant vessels and over 300,000 tons of shipping.
When the Germans started to deploy a fairly small number of the Focke-Wulf 200 Condors to attack Allied shipping, they were able to have really a devastating effect.
Also, had the new invention of a magnetic mine been dropped by Luftwaffe planes into the English Channel, its enemy could have been starved out of the war. This marks the first major failure of the Luftwaffe.
It was our common complaint of us, the little people, let's say, that there was no coordination whatsoever between the German Navy and the German Air Force.
With a stalemate on the Western Front, Germany decides to keep the British at bay and instead focus attention on their ally, the Soviet Union. Enacting a war plan known as Operation Barbarossa, some 3 million Nazi soldiers equipped with rifles, tanks and planes begin the biggest land assault in history. Using less than 3,000 aircraft, a force smaller than that utilized in the battle against France, Germany is miraculously able to push back Soviet forces to the suburbs of Moscow. The decision to launch Operation Barbarossa exposes the Luftwaffe to its second major failure, the lack of maintenance and repair on the ground. When a German aircraft is damaged, it is sent back to the fatherland for repair. When fighting a relatively short and tactical war against France, this particular system works fairly well. When fighting a long, drawn-out war of attrition against the communists, however, it proves to be a gigantic blunder. In the Soviet Union, with the fighting taking place far away from the major cities of Germany, the time it takes engineers to repair a damaged aircraft and have it sent back to the front is enormous. And by 1941, less than 30% of the Luftwaffe's airfields are operational, a fact that is almost inconceivable when taken into account that Germany is fighting a two-front struggle. As Field Marshal Erhard Milch would reflect after the war, the vertical organization in 4 territorial determined Luftflotte commands was grossly inadequate for launching a war well beyond the borders of the Third Reich. The attack of June 22, 1941 would in retrospect be a catastrophic mistake. For those like Göring, men who had never fought on the Eastern Front during the First World War, they would grossly underestimate the Soviet will and the industrial capacity of a regime thought to be so backwards by Hitler. Moving its factories far beyond the Ural Mountains, they are out of range of German bombers. The ghost of General Wefer comes back to haunt the Luftwaffe. After the Japanese attack on Pearl Harbor, Germany declares war against the United States. Before this decision is made, Hitler shrugs off any suggestion of a possible American threat in the form of an arsenal of democracy. In declaring war, Hitler foolishly adds yet another enemy to the Third Reich's list, one with a production capacity that is unparalleled. With 2 oceans separating America from the fighting, its people can go on producing without the threat of bombardment. Britain would have hauled the flag down long ago if it had not been for America's support, one field marshal said. With Germany by this time experiencing severe shortage of aluminium and copper, America is fully stocked of these and other vital raw materials. By 1944, the United States is able to churn out over 96,000 planes per year, one every 5 minutes, more than double that of the Germans. Before this catastrophic decision is made, it is important to note that by 1940, even Britain, with its shipping being torpedoed at an unprecedented rate, is outproducing Germany in aircraft. The British are able to improvise, and as a result produce outstanding planes like the de Havilland Mosquito, an aircraft made from plywood. In contrast, by 1941, with Nazi forces engaged in a two-front war, total production is just over 11,000 planes, a yearly increase of only 3,000 from when the war began. It is clear that the Third Reich's total output is only a fraction of what it could be.
One of the failures of the German Luftwaffe was their inability ever to work out a sane procurement and production process. Prototypes would be built and abandoned. They would be rebuilt and altered by Hitler's order and abandoned, and rebuilt a third time and perhaps put into production as an aircraft very, very different from what the original designers had intended.
This lack of planning and foresight can be attributed to the man who took control of Luftwaffe production in 1936, long before the war began. His name is Ernst Udet. An outstanding ace from the First World War, he is put in control by Göring, replacing Wilhelm Wimmer. His appointment to this powerful position marks the third, and possibly the greatest failure of the Luftwaffe.
Göring placed one of his World War I fighter ace buddies, Ernst Udet, in charge of technical developments. Udet really didn't know anything about this stuff.
Udet's forerunner, Wimmer, has been outstanding in overseeing the Luftwaffe's second-generation aircraft during the pre-war era, including the Me-109, the Junkers 87, and the Heinkel 111. With Udet as his replacement, however, the next line of aircraft is a far cry from their predecessors.
One of his hobby horses was dive bombers. He had seen, actually, in America, interestingly, between the wars, a demonstration of dive bombing, thought every German bomber should be made into a dive bomber, and then even ordered this new four-engine bomber, Heinkel 177, under development, to be made into a dive bomber. Well, Heinkel himself, who was, after all, an engineer who understood this, kept trying to talk him out of it, said this is ridiculous, but was overruled, and so they had to go back and strengthen the wings of the 177 to try to reduce drag so it could actually dive at high speeds. They tried mounting the engines in pairs instead of having four engines like you would normally think you would do on a bomber. They were mounted front and back in a single pod on each wing. This resulted in so much heat being generated that the engines were constantly overheating. So it really, I mean, it was a crazy idea, and it led directly to delays, and I guess you can really say the ultimate failure of Germany to field an effective four-engine bomber during the war.
The Heinkel 177, with its odd tandem engine arrangement and an insane requirement by Udet to dive bomb, makes this plane a complete disaster from start to finish. The aircraft becomes known as the dead racehorse, with only a handful ever getting the chance to fly.
The Heinkel 177 and the Me-210 go hand in hand as one of the Luftwaffe's major disasters.
The Messerschmitt 210, a replacement for the Me-110, is full of problems that are never ratified.
When he came up with his Messerschmitt 210, the RLF said, oh yes, that's very good, let's immediately, we'll order 10,000. Or whatever it was, but they went into mass production and the thing had hardly flown. It was a complete and utter disaster for Messerschmitt, which he'd never lived down, and they had to convert a lot of the built Me-210s into Me-410s by taking the aeroplanes to pieces again and reassembling them with new parts to turn it into a flyable and operational machine.
As one aircraft representative is overheard saying, everything turns to dust in Udet's hands. Only one aircraft, the Focke-Wulf 190, is considered a success under his watch. A reluctance to make the hard decisions also proves costly, as resources are diverted to projects that are simply unfeasible during wartime. By 1941, the need is for long-range strategic bombers, with America producing the B-17 Flying Fortress and the British reworking the Avro Manchester into the four-engine Avro Lancaster. Germany, in contrast, falls dramatically behind the Allies in producing four-engine bombers. Udet, with all his failures, commits suicide in 1941, leaving the Luftwaffe in shambles. With a Soviet victory at Stalingrad, German forces are pushed back, marking the beginning of the end. And as American and British bombers begin destroying German factories and city centers from the sky, the philosophy that General Weber endorsed years ago is coming true. Strategic bombing is proving vital in weakening the German war machine. Under the command of Field Marshal Erhard Milch, production is able to climb to 25,000 planes a year, a respectable increase, but nothing compared to what the Allies are able to produce.
U.S. procurement policies, which become a giant bureaucracy, embodied in the War Department and soon thereafter, World War II, embodied in the Pentagon. The Germans were simply not able to compete on that level.
In 1944, Germany is being outmaneuvered in the realm of aircraft by the rate of over 4 to 1. At this point, there is simply no way to compete with the United States or the Soviet Union. While much is written by historians about Allied coordination in resources and materials, little can be found about Germany's willingness to use its own allies' means of production to their advantage. This is yet another failure of the German Luftwaffe. Without a common goal and being on different sides of the world, the Empire of Japan cannot be considered Germany's biggest ally. Its most powerful friend during the war is instead the Italians. Unfortunately, with their own air force in shambles, the Nazis are reluctant to give them the licenses and the engines to build German planes on Italian soil. This proves to be a pivotal mistake, as Italy could have tripled aircraft production with German assistance, producing possibly 30,000 planes during the war. Also, Italian factories would have been out of bombing range for the Allies during the year 1942 and might have changed the outcome in the Mediterranean. Germany's other allies, Romania, Hungary and Finland, are all capable of making aircraft, but lack the knowledge and resources that the fatherland can provide. Had these nations been granted licenses to build Nazi aircraft on their own soil, there was a good chance that this coalition might have tipped the scale in favor of Germany during its pivotal battle against the Soviets during 1941. The decision not to fully utilize the resources of these nations can be attributed to Germany's desire to be the dominant power. There is widespread resentment against the Italians by top Nazi leaders who see them as merely riding off the coattails of German success.
Our feeling always was, with the experience of the First World War already, we wish the Italians were on the other side.
People like Hermann Göring see these smaller countries as the providers of natural resources, with the fatherland supplying the finished products. This marks another tragic failure of the Luftwaffe. In early 1944, Germany unveils the Messerschmitt 262, a revolutionary jet plane that can hopefully take down the flying fortresses and mosquitoes that are destroying their cities.
Later on, of course, they produced the world's first production model, general use jet aircraft in the form of the Messerschmitt 262, the Me-262. The Me-262 as a pure fighter was an amazing sight to see, and in fact, anyone looking at it today is still struck by the modern and sleek lines.
Now, the Me-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II.
The Me-262 is years ahead of its time, symbolizing the fatherland's creativity and innovation. In many ways, however, the Me-262 also symbolizes Nazi indecision.
Unfortunately, the Me-262 got caught in a very, very arcane and difficult procurement process within Germany, wherein basic designs were put forward by competent engineers. They were then changed by upper echelons within the Luftwaffe, and of course they had to pass the Hitler test. And no aircraft passed the Hitler test without being significantly modified. The Me-262 is no exception.
After Professor Messerschmitt tells Hitler that the aircraft can carry up to 1,000 kilograms of bombs, Field Marshal Milch, in a fit of rage, tells the Führer that even the smallest infant can see that the 262 is a fighter, not a bomber. After months of wavering, the plane goes ahead as a fighter-bomber, taking the sting out of what could have been a ferocious punch. They may possess this wonder weapon, but have few men that can fly it. This becomes the Luftwaffe's final failure, its pilots' lack of training. During its heyday, Germany's finest were given approximately 250 hours of flight time before being sent out to face their enemy, considerably more than the British. And with the Second World War going exceedingly well during 1940 and 1941, the Luftwaffe arrogantly minimizes its training program, figuring that the war will soon be over. By 1942, as the tide begins turning, German pilots are given less than 200 hours of practice flying, while Allied pilots are given over 300. With the war turning against them, shortcuts are made to churn out every single pilot possible. Despite this augmentation, by 1944 the average training time drops to just under 100 hours. In some cases, just a quarter of what P-51 Mustang and P-47 Thunderbolt pilots were given. With air superiority lost over German soil, it becomes a turkey shoot for American and British aviators as they begin gunning down Me-109s and Focke-Wulf 190s with ease.
At D-Day, in the final planning, the head of Allied tactical aviation was asked, well, what are we going to do about the German fighters? He said there aren't going to be any German fighters over the landing beaches. And he was essentially right, because they'd been wiped out by then.
The decision not to build a pilot training infrastructure like its enemies causes the Luftwaffe to run desperately short on experienced men. So by the time planes like the Me-262, the Arado 234 jet bomber, the Me-163, a rocket-powered interceptor, the Dornier 335 Arrow, the fastest piston engine plane of the Second World War, and all the other revolutionary aircraft that could have been the difference maker on both fronts, it is a case of too little, too late. The defeat of the Luftwaffe can be attributed to its lack of direction. With the war going in Germany's favor, Hitler, Göring, and Udet were blinded by a false optimism. That tactical war doctrine that they favored initially was being replaced by a long, drawn-out strategic war that they were ill prepared for. The arrogant nature in which they brushed off the industrial power of the United States and the Soviet Union. The mismanagement of their own country's aircraft industry on a grand scale, and the lack of infrastructure, production, and training during the Second World War's most decisive years would cause the Luftwaffe to write its own epitaph.
Well, the Messerschmitt 262, in my opinion, was the most formidable fighter of World War II. They had the advantage of, when they designed this, of supersonic wind tunnels. That is clearly shown in the fuselage shape of the 262. They were also well aware of the advantages of sweepback in easing your way through the transonic speed area. The aircraft was designed with these things in mind. So it was going to be a jump ahead of its time, so to speak. When I first saw it, I realized that this was a very different looking airplane. But also, at that time, I hadn't fully realized just the impact its engines were going to have, because we, in the early jet stages in Britain, were using engines operating on the centrifugal principle. of jet propulsion. The Germans started off in that area as well, but they had a sector that went onto axial flow. And of course, today every jet engine is axial flow. They were on the right track right away. But having said that they're on the right track, I must divert for a minute, because was it the right track at that time? I worked closely with Frank Whittle, who was invented or developed the jet engine. And I knew he knew all about the axial flow engine. I said to him, Frank, why have we gone centrifugal when the Germans are going axial? And he said, because in the early stages of jet propulsion, I want to give our Air Force an engine that is simple and reliable. Now, how right he was, because in the early stages, the German jet engines, whereas Frank Whittle's centrifugal engine had an overhaul life of 100 hours, you overhauled it, the German axial flow jet engines had a scrap life of 25 hours because they didn't have the strategic metals to withstand the heat stresses at that time. So, temporarily, we were on the right track. But eventually, of course, the axial flow offered advantages in streamlining, because for a given power, you had smaller compressor and turbine discs. And also, of course, it had better specific fuel consumption. And altogether, they were on the right track there. But unfortunately, they couldn't go to the ultimate because, as I said, they hadn't the right metals. However, as an airplane, this was something quite electrifying to fly. The cockpit, there was nothing particularly unusual. It wasn't a cluttered cockpit. It was quite simple, and it had the functional things here, and the engine instruments on the right, and generally good view, good canopy view, and being a tricycle, you had a good view ahead. So altogether, they had a lot going for it, apart from this unreliability of the engines. Even when they were in the air, they were very sensitive to throttle movement. Excessive movement, either accelerating or decelerating, could flame out the engines. And it got so bad, in fact, that eventually the way the Germans were operating was to take off at full power, then ease slowly back to climbing power, and never touch the engines thereafter until you were coming into land. They took that risk, and this didn't pay off, I don't think, because, as I say, although it has a scrap life of, theoretically, of 25 hours, but Adolf Galland told me at the end of the war that his unit, flying the 262 JG-44 at the end of the war, was only having an engine life average of 12.5 hours. So it goes to show what the vulnerability of that was. Firepower on this airplane, huge. 4 30mm cannon. They had forgotten one thing, and we did the same with our initial experimental jet aircraft. They had forgotten how to slow it down. They did not have dive brakes. And this cost them a little because the aircraft was built mainly to deal with the B-17 Flying Fortress bombers. And when you came in on a dive to attack them, your closing speed was huge, and you couldn't open fire because of the inaccuracy of the guns above 600 yards. So let's say you opened fire at 600, you had 2 seconds before you had to break away because your closing speed was so high. If they'd had dive brakes, that could have doubled the closing speed. Now with a closing speed of 2 seconds, you're firing at random. You're not sighting, you're just pressing the button and hoping you're pointing in the right direction. With 4 seconds, you can quickly sight, adjust and fire. So it made a big difference. Now the Me-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II. When you consider that at the end of the war, the top Allied fighter was the Spitfire Mark 14 with a top speed of 446 miles an hour. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance, and it meant the 262 was virtually inviolate. It also handled quite well in the air. It had no nasty characteristics really, except if you lost an engine on takeoff before you reached safety speed. But apart from that, I was very impressed. It had 2 shortcomings, but all the early jets did in our country, in America and in Germany. Firstly, the engines were very sensitive. They were slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, we hadn't thought, or the designers hadn't thought, of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing. You need some drag if you're going to land, and since there was very little drag associated with the 262, you had to do a long, slow approach to landing. And this was an Achilles heel, because the 8th USAF Mustangs realized this, and the few 262s they picked off was usually in that phase of the operation. Of the 3 great airplanes I think the Germans produced in the war, I would say the Ju-88, the Focke-Wulf 190, and the Me-262 were the 3. The Ju-88, in my opinion, was a first-class medium bomber. The Ju-88 G4, for example, had a top speed of 400 miles an hour, which was 6 miles an hour faster than the 190 PA4 at that time, its contemporary fighter. So it was a formidable airplane. And also the Germans had learned from the mistakes of the previous medium bomber, the Heinkel 111, where you had the crew separated by the bomb bay. You had the flying crew up to the front and the defensive crew at the back. But there could be a breakdown in communication. And also, there could be a breakdown in morale if you have the 2 separated. They had learned to put the 4 crew of the Ju-88 into one glass house, I think you would call it, on the fuselage. And the crews themselves were very enthusiastic about the airplane. I flew it quite a lot, that and the 188. The 188 had a rather different rudder effect, and I would say it had improved slightly over the Ju-88, but a negligible amount. It still had the good flying characteristics of the 88, in fact, slightly better. And I was very impressed with both types of aircraft. The Focke-Wulf 190, as a fighter, was first class. There's no question of that. It was an outstanding airplane. And inevitably, as the war progressed, there were attempts made to keep up with the hunt, so to speak, and give it a variety of roles. And there were many different marks of 190, and it eventually gravitated into the fighter bomber. In that role, it was quite effective, actually. Fighter bombers have a limited role. They are used against what I call targets of opportunity. You don't use them to come in and bomb an industrial layout. What you do is you use them to shoot up trains or convoys you see on the road. And from this way, the Focke-Wulf 190 was very effective again. So it was a versatile aircraft. And as it progressed, it eventually had an engine change. The Dora, the later Dora, was a magnificent fighter with an engine change and not really any structural changes other than those to accommodate the engine. But what it meant was, here was an airplane that could keep up with the hunt as the years of the war progressed. So from 1942 right up to the end of the war, the Focke-Wulf 190 was in the top grade of fighter or fighter bomber.
The next series of films highlights the development and testing of the Me-163B. The B model was the ultimate version of the Me-163 line. This was the actual combat version of the aircraft. The vast majority of Me-163B flights were for development purposes, however, although the aircraft did finally see limited combat experience beginning in the middle of 1944. You'll note that there are significant shape differences between the Me-163B and the earlier A model and the DFS 194. The landing gear is substantially more robust on the B model than it was on the earlier A model. Here we can see a couple of ground crew members wrestling the jettisonable takeoff gear into place. We can also see the extensible landing gear as well. The Me-163B was a much larger aircraft than the earlier A model, where a pilot could easily just flop over the side of the canopy sill on the A model. A ladder was required for access to the cockpit on the B model. As the canopy closes, we can see an air vent at the leading edge of the canopy. You'll note also that the canopy is hinged to the side on the B model, whereas on the A model it was hinged to the rear. Here we see the servicing cart for the turbine being rolled away from the aircraft. There was a turbine inside the Me-163B which drove the fuel pumps for the T-Stuff and C-Stuff propellants that powered the Walter rocket motor. We can catch glimpses of the extensible tail wheel at the aft end of the Me-163B in some of these shots. This has changed from a tail skid on the A model. On the early B models, this tail wheel was unfaired. In some of the later B models that we will see later in this film, a fairing is constructed around that tail wheel to improve aerodynamic efficiency. As with the earlier members of the Me-163 family, including the DFS 194, climb performance for the B model was simply outstanding. Again, the aircraft was capable of climbing from a standing start to roughly 40,000 feet in 3 to 3.5 minutes. While the aircraft's performance was remarkable, this performance has to be balanced against the fact that it took a long time to prepare an Me-163B for flight. Unlike conventional combat aircraft used by the Luftwaffe, such as the Focke-Wulf 190 or the Me-109, you couldn't simply scramble an Me-163 to meet an oncoming threat. After the aircraft came to a stop, clearing it from the airfield was a major challenge, and a device was created to do that, the German name of which I won't even begin to try to pronounce. This device had airbags that were inflated under the wings of the aircraft, lifting it off the ground and enabling it to be removed from the field. It was later replaced by a device that used rigid arms instead of inflatable airbags. In these head-on shots of an Me-163B, there's a couple notable things here. First is the propeller at the very nose of the aircraft. This was used to drive a small electrical generator, which would be used to power instrumentation and radios on board the aircraft. Also visible in those shots, just above the well for the landing skid, was a small hole where a tow line could be attached. Most Me-163 flights of all members of the series were done in an unpowered mode, glide flights, generally using an Me-110 as a tow aircraft. Landing skid failures were fairly frequent with the Comet. The landing skid was hydraulically extended, and frequently that hydraulic system would fail. The next series of shots are going to give us some wonderful views of some of the interesting details on the Me-163B. Here, very noticeable is a flap, an undersurface wing flap that is partially extended. Note that those flaps fit onto the surface of the wing and are not recessed into the wing. Also notable here is the extended tail wheel. Note that this is a later Me-163B and that it has the fairing on the tail wheel. In just a moment, we're going to get some very good shots of the aft end of the aircraft. You can see here that smoke is still pouring from the nozzle of the Walter rocket engine. We mentioned earlier that the takeoff roll was especially difficult for Me-163 pilots. In addition to just the sheer length of the roll, directional stability was a problem during the early portion of the roll before the rudder became effective. A device called the Strahl rudder was tested on both the A and B models that would fit into the exhaust of the Walter rocket engine to give the pilot a bit of additional directional control during the early takeoff roll. Here we see the airbag version of the aircraft transporter in use. The next sequence of shots is especially fascinating because it gives us some glimpses of some of the more significant figures in the history of the Me-163. The woman in this photo is Hannah Reitsch. She was a prominent test pilot in Nazi Germany, a personal friend of Adolf Hitler, and she had campaigned heavily to be given the opportunity to fly the Me-163. The tall gentleman with sunglasses and a protective overcoat on is Heinrich Dittmar, who was one of the early test pilots very closely associated with the Me-163 program. We'll come back to the story of Hannah Reitsch in just a moment. Here we see some footage showing testing of a motor on an Me-163. A couple things are notable here. First, there's a protective cover that's been placed on the aft edge of the rudder. You can also see in several of these shots Mach diamonds in the exhaust plume. That's indicative of the supersonic flow coming out of the engine. Here we have an Me-163B taking off from a paved runway. This would have been a much preferable experience for the pilots to take off on an unimproved airfield. Another change that took place with the landing gear late in the program involved the landing gear. The early landing gear used on both the A and B models was rigid with no suspension. Not only were the takeoffs hard on the pilots, but they were hard on the aircraft as well. So eventually, shock absorbers were built into that takeoff gear to protect both the pilots and the aircraft itself. Here we have an Me-163B on tow behind an Me-110 tow aircraft. Most Me-163 testing and training occurred not under rocket power, but on towed flights. Let's move back to the story of Hannah Reich in the Me-163. Again, she had campaigned fairly aggressively to be given the opportunity to fly this aircraft, and she ended up flying the Comet a total of 5 times. On her final flight in the Comet, the takeoff gear failed to release just after takeoff, and she was forced to return to the field for a very hard landing. Her injuries were such that she was kept out of the cockpit for the next 5 months and never did fly the Comet again. The next series of films shows another individual who's very closely associated with the Comet program, Rudi Opitz. He, like Reich and Dittmar, was a very experienced glider pilot, and as such was especially valuable to the Me-163 program. Here we see him getting into an Me-163B. You'll note the machine gun protruding from the leading edge of the wing there. Also visible in many of these shots is the very thick piece of armored glass immediately in front of the pilot. Again, this was a combat aircraft at this point, and that piece of glass, along with an armored nose cone, was designed to protect the pilots as they flew straight at approaching Allied forces. In all likelihood, this is yet another test flight for the Comet. You'll note the very large data acquisition camera that Opitz has bolted to his head there in many of these shots. That's a spring-driven camera that the pilot can use to take photographs of the instrument panel during critical portions of the flight. It's certainly a far cry from the digital data acquisition equipment used on test aircraft today, and even a far cry from the crude analog systems used in the late 40s through the 50s and 60s.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.